Thank you, everyone. Professor Reddy, if I may request you to please turn on your camera so that we can start. Sukanya, can we start? Have you started letting the participants in?
Yes, Sachin. I'm just going live now.
We are going live now? Okay, excellent. All right, okay. So then let us start. Hello and welcome all the colleagues. Thank you all so much for joining us today. I am Atin Biswas and I'm your host today with my senior colleague Siddharth. We are part of the Solid Waste Management and Circular Economy Unit at the Center for Science and Environment. This is the first webinar in the run-up to the fifth and final International Negotiating Committee meeting in Busan, South Korea, end of this month, to deliver the much-awaited Global Plastic Treaty. We have two more webinars scheduled on the 13th and the 19th, so do register for those as well. I'll post the announcement and the registration link in the chat box as soon as the discussion begins. Let me now try and give you all a quick context to the discussion we are going to have today. In our endeavor to deal with plastic pollution, our focus has largely been to manage plastic waste. We almost lost sight of the bigger problem, and that is how increased production and consumption of plastic is leading to serious health issues. Thankfully, the ongoing negotiations around the Global Plastic Treaty recognized plastic pollution in its entire life cycle, typically divided into upstream, midstream, and downstream challenges. In India, some very good scientific research have been done by premier public institutions that has provided us with enough scientific evidence to identify the risk and find measures to mitigate them. And surprisingly, in India, many of these studies have been done as much as 10 to 12 years back. And there are many scientific reports available globally talking about the gravity of the problem and giving us all the reasons to act sooner. Needless to mention that now is the time to address them with strong regulations and enforcement, ideally in consultation with scientists and medical practitioners. Today, we are extremely privileged to be joined by a pool of amazing Indian and international panelists to share the wealth of their experience and expertise while they reflect on the issue. We shall introduce them to all of you when we invite them to speak. Now, some housekeeping announcement. The webinar is largely divided into three sections. In the first part, my colleague Siddharth, who also leads all our research around plastics, will make a small presentation to highlight the plastic and human health issues in upstream, midstream, and downstream agenda with some specific reference from India. In the second part, we'll invite the panelists and we'll hear the insights from them. In the third part, we'll be taking as many as questions as possible from the participants. So please keep posting your questions, ideally in the Q&A box so that it is easier for us to pick up. Now, without wasting any further time, let me give the floor to Siddharth. Siddharth, now the floor is yours.
Yeah, the presentation.
Yeah, let me upload. Yeah.
Hello, everyone. I hope you all can hear me. I will be running you through a very short presentation, which are essentially case studies from India. A disclaimer before I start: none of the work that we are going to share here today is CSE's own work. It is all derived from cases that have been filed in the National Green Tribunal, which is the Green Court in India, which looks at all the environmental issues. So before I start, let us first try and understand how the plastic life cycle looks like. Right. So this is a schematic that was developed by the Monaco Convention. And here what we see is, I'm sure you might have all heard about upstream, midstream, downstream measures, or across the life cycle, how these terminologies are used. So as we know that 99% of the plastics that we use today are derived from fossil fuels, right? So that is where the production stage comes in. So you extract crude oil from the belly of the earth, and then you basically convert it into naphtha. The larger hydrocarbon chain are cracked into smaller units, which are called monomers. These monomers are then polymerized to arrive at polymers, which we generally call as plastics. These plastics can have many forms. One of the few widely used polymers or plastics are polyethylene and polypropylene, right? So this is the upstream or the production side. You extract crude oil, you do some unit operations, and then you attain monomers, which are then polymerized to get polymers. These polymers can be in a powder, pellet, or a paste form. These, what we call virgin plastic or primary plastic polymers, then again go through a thermal cycle and are converted into different different products which may be used for various applications such as packaging, transportation, medical, etc., etc. And then these all of these plastic products have a mean service life, right? So they may be used for a few seconds, a few minutes, or some may be used for a few years. But all of them have the same fate, which is all of them are discarded. And once they are discarded, they have to be treated or processed or recycled using several technological or technical interventions. So the stage where we are working on virgin pellets or primary plastic polymers and converting them into products is the midstream part. And the phase when we discard them and have to rely on technology to try and bring them back into the value chain is the downstream or the disposal part. So what I'm trying to do today is basically taking references from cases that have been filed in the National Green Tribunal uh, and divided them into these three categories of upstream, midstream, and downstream. Uh, yeah. So for the upstream measure, we are essentially looking at refineries. There are a few cases which have had hearings in the National Green Tribunal. The and these are all recent cases. These are not very old cases, but the one that I have personally visited this refinery is the Indian Oil Corporation in Panipat. Uh, a case was filed by the local villagers against the refinery, and the refinery was accused of contaminating the groundwater, deteriorating the air quality, and also affecting human health. Uh, a similar case, not really similar, but a case again against a refinery was filed in 2023 when this particular refinery in the state of Tamil Nadu was accused of discharging crude oil during a cyclone Michong, which occurred in the year 2023. Now, the second case, the Chennai Petrochemical Corporation Limited case, is still ongoing, and we have members in the panel who could throw more light on this. But since I have personally visited Panipat, I have interacted with the general physicians there. I have been told that uh, babies as young as 5 years old have to rely on nebulizers every single day just because the air quality there is not really up to the mark. A committee was set up with the Central Pollution Control Board, the State Pollution Control Board, and CSIR NERI. And what this committee tried to do is arrive at a cost for the damage caused to the environment and also to the public health. Now, this cost was calculated to be somewhere around 92.59 crores, which translates to roughly about 11 million US dollars. And there was a methodology that was found all of these reports are also at the CSE landing page for this webinar. I will share the link to all of these after I am done with my presentation. Now, of the 92.5 crores that was basically slapped as an environmental compensation on this refinery, uh, only about 17 to 18 crores has been recovered till date, as per information from the local people. Apart from this, there was a case in 2020 when a polystyrene production plant, which was run by LG Polymers, uh, faced a gas leak. This unit was operational in Visakhapatnam or Vizag, and there was a styrene gas leak in 2020, right after COVID, when the plant was trying to operationalize, and as many as 11 people lost their lives during this incident. So there are evidences from within the Indian context where we have documentation on how the upstream measures or the production of plastic is actually impacting human health, and we also have figures around how much did this cost. For the CPCL plant, the 2023 case that is still ongoing in NGT, the latest update is that an environmental compensation of about 65 crore rupees has been slapped against this refinery, and it is for damage to the environment, damage to human health, and also to biodiversity. And the distribution is 50% for biodiversity and around 50% for human health and for environment. I think, can we have the next slide? In the midstream, actually, this is very interesting because these this case, the Him Jagriti case, it was filed by a local NGO in Himachal Pradesh, and following which uh, the National Green Tribunal had directed CSIR, Indian Institute of Toxicological Research, which is based in Lucknow, and the All India Institute of Hygiene and Public Health, which was then under the Ministry of Health and Family Welfare. Both these organizations, which are pretty much government organizations, came up with reports. Now, the CSIR IITR report, if you look at the table on the right side, um, you can see that they conducted a few tests. So we are looking at, there were several parameters that were tested. Uh, the table 2 shows or talks about how much of diethyl hexyl phthalate, which is DEHP, which is a phthalate that is used as a plasticizer or as an additive in the production of plastics, how much of it was leaching out into the product itself. So as you can see, the highest leaching was observed in hair oil, which was around 5.3, and for aerated drinks, again the number was around 0.078, and this was observed at not a very high temperature, at around 40 degrees Celsius. Now, 40 degrees Celsius is something that every summer, every Indian city sees this temperature. This becomes our room temperature in at least the summers, right? Uh, Another parameter that was tested was lead samples. And as you can see, in aerated drinks, in cough syrups, the leaching was quite high. It was definitely above the detectable limits or the limit of quantification. Now, what does this exactly mean? Okay, fine, these chemicals are leaching into our products that are packaged in plastic, which is, time and again we are said that PET is safe to use. But what do these actually mean? Now, the All India Institute of Hygiene and Public Health, uh, in its report, mentioned that there are no safe levels of exposure to lead, right? And every year, this is 10-year-old data. I'm talking about this report is from 2015, and we have not really done any technological changes to now believe that these chemicals today have stopped leaching into our products, right? So as many as 143,000 deaths happen every year, with the highest burden on developing regions. Of this, the Southeast Asian region is the highest affected. And lead, if a human body is exposed to lead, is distributed in the brain, liver, kidney, and bones, and it can be detected by taking blood samples and measuring them. Now, the phthalates that we discussed, the phthalates that we saw in the first table. So this report said it obviously drawn reference from a lot of literature that was already available at that point of time. Uh, this report said that if a DEHP metabolite was found in the mother's urine, then the penile width, the testicular descent of the male offspring was affected right from the beginning, right? And in adults, there was some evidence of negative association between finding phthalates and the quality of semen. So, which means that the reproductive health of a person is affected right from the word go, right from the day we are born or we come into this world. That was about the midstream. Now, if you come at downstream, where we talk about the disposal phase, there was this article that was done in 2024 by one of our colleagues, Swati Sambyal. It was published in the Indian Development Review, and based on this report, a suo motu case was filed in the National Green Tribunal, and today, India is actually looking at pushing waste to energy, incineration-based solutions as a quick fix for managing all our waste-related issues. Now, this NGT report, again, this is NGT directed CSIR NERI to look into this matter. And NERI in its report mentioned that mixed waste is likely to contain chlorinated plastic, which is essentially polyvinyl chloride, which is widely used in wirings, in taps, in agricultural purposes, highly used for packaging. So there's very high chances that this type of plastic is found in our mixed waste. And if the temperature of incineration drops to less than 850 degrees Celsius, then there is high chances of formation of dioxins and furans, which are very toxic, right? And also incomplete combustion releases carbon monoxide, nitrogen oxide, sulfur dioxide, all of which would be above permissible limits. So this is the context for today. I think I can request you to stop sharing the screen. This is what evidence we have from India. I'm sure there are many more, but these are the most recent over the last 10 years. Some, if you look at the upstream part, not more than 6 years back. So this is the evidence that we have from India. Now, with this as the context, I would now want to start inviting my panel. So first in line, I have David Azule. He is affiliated with the Center for International Environmental Law and is the managing attorney uh, in CL's Geneva office and is also the director of CL's Environmental Health Program. He comes to CL from Friends of Earth Europe in Brussels, where he coordinated their chemical and nanotechnologies campaign. David also co-leads CL's plastic work, examining the environmental health aspects of plastics and coordinating civil society's engagement in global policies forum such as the United Nations Environment Assembly and the Basel Convention. He's also a member of IPEN's steering committee. So, David, the floor is yours. And as we've discussed, I would want you to focus on what literature do we have around what kind of chemicals go into plastic. And I'm aware that CL also did last year a comprehensive report on plastics and human health. So if you could throw some light on that.
Thank you very much, Siddharth, and good afternoon, good evening, everybody. I will try to share some slides, so let me just bear with me a minute while I try to get this right. Let me see if this will work. Can you see my slides now? Yes?
Yes, we can see it, David. You can go full screen if it is possible.
Yes,
You just
of
hit the
course.
slideshow button, I guess.
Okay. Oh, it should be loading now. Yep. Is
Yeah,
that
perfect.
Go
Go
fine
ahead.
now?
Yeah, it's great.
All right. Before getting into the details of the question, I was also asked to provide some background or some very basic information about what exactly are we talking about when we're talking about plastic? Because we all know plastic objects, plastic products, we use them every day. They're present in every aspect of our everyday lives. But there isn't always a good understanding of what the material is actually made of. And to understand the potential health impacts, it's important to go back to the basics and what plastics actually is. And I'm going to use a very basic analogy, and hopefully I'm not going to make you either too hungry or it's something that will speak to you all. But as Siddharth was saying, the core element of plastics are long carbonated chains of polymers. Think of them a little as the spaghettis that you can see on this. We're talking about, again, very long and chains of carbon-based. Those are the polymers, and they're what forms the basic architecture of plastics. But of course, in the plastics objects that we have in front of us, whether my glasses or anything else that you're using right now, packaging or elsewhere, it's not just about the polymers. It comes with a very large assortment of additives and other substances. Anything to make plastic flexible or hard or transparent or colorful or water resistant or impermeable to air, etc. And these gets added to the long chain of polymers in quite complex chemical processes that usually take place in refineries and after the crackers. And what you get in the end is something like this. This is the plastic. This is the plastic material that then gets turned into every single object. And I want you to notice a couple of things around this. First of all, again, the wide variety of substances that make up the final product. And also one thing you'll notice is that in the final products, a lot of the ingredients that you've put in have changed forms and are therefore difficult to track or are needed. It's necessary to understand what they've become through the different chemical processes that they've gone through to be mixed and combined with the polymers. And one of this that this analogy doesn't fully capture, I'm sorry, is that in addition to what you add to the polymers to give it specific properties, the long complex chemical process of manufacturing each of those additional ingredients and binding them together also adds a number of what we call non-intentionally added substances. So again, plastic as we know it, and when we're discussing about possible impacts of plastics, we're talking about long chains of carbonated polymers, a very large variety of additional substances, chemical substances, and non-intentionally added substances. So what exactly are we talking about, and how many of those are we talking about? It turns out that last year, scientists from around the world got together to prepare this very extensive report on the state of science on plastic chemicals. And the idea of this report was to go a little deeper and understand what exactly are the chemicals that are part of the plastic materials, where we find them, what do we know about their toxicity, and what do we not know about their toxicity, and also try to understand how and whether they are regulated. The basic conclusions from this report are shown on the slides here. They have identified over 16,000 chemicals that are present in plastics overall. However, of those 16,000 chemicals, only 6% are actually registered internationally and are regulated internationally. Over those 16,000 chemicals, there are a large number of chemicals of concern. 4,200 chemicals are identified and already classified as bioaccumulative, mobile, and have a large number of hazards impacts. It's our carcinogenicity, mutability. And so those are chemicals that we know have severe impacts on human health. And that's already quite a large number of chemicals. But what is even more worrying than this, I would say, is that out of the 16,000 chemicals, the vast majority of them are not actually, uh, we don't have the hazard data. We don't know what the impacts of those chemicals are. For some, we have some level information. We can infer some information because we know what families they belong to and what the impacts of those families of chemicals are. But this is a major problem because, as those of you who are versed into risk assessment and toxicology know, what you need what you need to do a proper risk assessment is first understand the hazards, then understand the exposure. So what are the hazards? What do the chemicals do when they interact with our body or with the environment? The exposure is how much of it are we or the environment exposed to? And from those two elements, you can derive an actual risk that can help you derive some risk management measures. However, we have incomplete hazard data, but also because there is very little transparency throughout the supply chains. Workers at different steps of the supply chain have no idea what are the chemicals that are included in the material that they're dealing with. We also don't have adequate exposure data. But what we understand is that they have high exposure potential because their presence in a very large variety of products that, again, we interact with in our everyday life. And so this is some of the issues, some of the toxicity that was identified about those chemicals, or some of the toxic characteristic of those chemicals include some of the most problematic toxicity classes and hazards, including endocrine disruptors. Siddharth, in his previous presentation, talked about a number of phthalates that were leaching from food containers into the foods. You're all probably, or you will have heard of bisphenols that are also widely present, or PFAS, so-called forever chemicals, because they don't break down, and once they're out in the environment, they just do not degrade and are found everywhere. And each of those chemicals, and we're going to get a little more into this, are linked to very serious health impacts, including cancer, reproductive toxicity, and immune system impairment. Now, those are not just words on the pages. Those are actually impacts that we're all familiar with, either in our own body or in the people that are around us and our loved one. I'm sure that I could ask anyone attending this webinar, and everybody knows someone who has been suffering or battling cancer one way or the other. Reproductive toxicity is also something that we're all very familiar with. We all know about families or couples who are struggling to procreate and to have children. One just quick number that usually mark the quality and quantity, the quantity of spermatozoid in male semen has decreased by 50% over the past 50 years. And the curve that we're looking at is trending towards zero, meaning that if we don't do anything to reduce the exposure to some of those endocrine disrupting chemicals, it is very likely that we're effectively preventing the human species to procreate and reproduce. And those chemicals, both the plastic material itself, again, the polymer, the particles of the plastics and their individual chemicals have been found everywhere on the planet and in our body that we have been looking for them. That is something that is really quite mind-boggling and quite important to understand. Again, as I mentioned at the beginning, the plastic material is the combination of different things. And when we look at the toxicity of plastic, there are two types of toxicity that we need to consider. The physical impact of the particle, the microplastic or nanoplastics, once it enters the environment or when it enters our body and our organ, and the specific toxicity that the chemicals that are associated, that are part of those microparticles, have on our body and on our health system. Now, those chemicals, all those 16,000 chemicals that I've been talking to you about, they travel around the environment and they are present, again, everywhere we've looked for, from the highest glaciers in every single mountain chains, and man never sets foot in those areas, but the microplastic travels there through air current and through environmental systems. So through the highest glaciers to the most remote deserts, to the deepest areas in the ocean, against where man never goes, we have sent plastics. Within our body, there has been a multiplication of studies over the past few years looking for the presence of plastics, microplastics, and nanoplastics in different types of organ within our body. The result of those research is everywhere you look for microplastic, you find it, whether it's in the liver, the kidneys, the brain, the placenta of pregnant women, in the umbilical blood of a newborn, in breast milk that is being used. Everywhere you look for plastic, you can find it. And that is an issue because that tells you about the extremely high exposure and extremely versatile exposure that we're dealing with. Now, Siddharth mentioned one part about the whole impacts of plastic and what is plastic pollution. And because we're also talking about possible regulation here, I want to go back to how to define plastic pollution. For a long time, we've identified plastic pollution as the pieces of plastic packaging that are in the environment, floating in our waterways or elsewhere. But plastic pollution is much more broadly defined as all emissions and risks arising from the production, use, waste management, and leakage of plastic. And it's important because, as Siddharth was alluding to earlier, the life cycle of plastic is diverse and is quite complex. It starts with the extraction of oil or gas. Now, a lot of it is done via fracking. It is then being transported to plastic production, and plastic production is actually a little more complex than just this particular drawing, because it means transforming the oil into the different components and then combining those different components together to create plastic pellets, small thing, and then turning those plastic pellets into actual product, whether it's a food packaging or a bike handle or a car bumper or a medical bag for transfusion, etc. So from there, it goes into the market, and then it goes distributed to consumers, whether professional or industrial or individual consumers. Once the consumers have used the products, and remember, about 45% of the plastic that we use will be used only once for just a few minutes. It's called single-use plastic, and it's a material that will last thousands of years, but that we're using just for a few seconds or a few minutes. Then it becomes waste, and then waste needs to be dealt with, and a lot of it is traded around the world, buried, or as Siddharth was also mentioning, openly burned, or burnt to recuperate energy with the severe impact that we know of. And then it very often, a large part of it still ends up directly in the environment or in landfills. That's about 80% of every plastic that was ever produced and consumed ends up directly into the environment and into landfills. And remember, once it's in the environment, even if you don't see it, it will degrade into very, very small particles that will then end up in our bodies and every single organ of our bodies. Now, I've touched a little bit about this already, but there are quite a number and very well documented health impacts on a lot of systems and functions in our own bodies. You can look at the slide, or you'll be able to look at the slide in a little more details once it is shared with the participants. But again, the health impacts that have been identified, and again, here what we're talking about are health impacts that are well documented and identified, are the result of exposure to the particle itself, where the particle can disrupt the functioning of an organ, and the function, or from the chemicals that are associated, that are part of the particle, and that will leach out and be transported by the microparticle everywhere in our bodies. As Siddharth was mentioning, TL has been producing a study a few years ago looking at what are all the various health impacts that exist at every single stage of the life cycle of plastics. Again, trying to identify the latest studies, separating both the sources that are either from the microplastic or from the chemicals, and the various ways of exposure. We're exposed to plastic in a lot of different ways. We're quite familiar with the idea that we eat it, because again, microplastic have been found in every single piece of food that has been tested all around the world. Again, these are studies that are very much global, and the level of exposure is the same whether you're looking at what's happening in the United States, in Europe, in India, in Africa, or in Pacific Islands, or in South America. The level of exposure is very much similar. So we know we're eating microplastic, and then they get into our guts, and from our guts into the rest of our body. But what you may not be so familiar with is that we in fact inhale, breathe in even more plastic that we currently eat. And we inhale it because plastic as it degrades, transforms into microplastic, gets into the air, and gets transported all around the environment. Now, we've identified that as well as there is a water cycle on our whole planet, there is also a microplastic cycle where microplastic are vaporized, are aerosolized in waves from the ocean, get into the atmosphere, get transported into the atmosphere, and go back, and it's just an additional cycle that we've added, natural cycle that we've added to the water or carbon cycle into our atmosphere. And so we ingest it, we inhale it, and we also get in contact with it, because most of what we wear is actually made out of plastic. And through the wearing, through the contact from our skin, we're also exposed to a lot of those chemicals. And again, at each particular stage, there are identified effects on the immune system, on sensory organ, on the liver, on kidneys, on low birth weights, on reproductive system, on brain mechanism. I'm not getting into the details here, but I mean, there is a lot of literature that is quoted in the various reports that I'm quoting, both the PLASCAM report and this CL report on the health impact at every stage of the life cycle. And I invite you to look at the detail, but we're talking about thousands of studies documenting thousands of specific impacts, both from the plastic particles and from the chemicals. Now, Siddharth talked about the context. We're having this discussion because there are things that can be done about it. We're currently in the process, the world is currently in the process of negotiating a plastic treaty, which objective is identified as ending plastic pollution. Again, plastic pollution being defined very widely as all emissions and risk from every stage of the life cycle. In the context of this plastic treaty, this negotiation started in March 2022 with a mandate that was given to all countries. It now is a process that involves every single country on the planet coming together and having discussions. Those discussions look more or less how you can see on the slides behind me, and trying to adopt control measures and provisions that would apply globally. And it's particularly important to think of applying globally because plastic is a global problem. The fossil fuel that is extracted in different points on the planet, is exported all around the planet, including to India, to be transformed into plastic pellets. Those plastic pellets themselves are then exported all around the world to be transformed into plastic products. Plastic products, including food packaging or other pieces, are then exported all around the world to be consumed. And once they become waste, those wastes themselves get exported and transported all around the world. And so there is no possible way that any country could protect itself from the negative impacts of plastic all and of its own. This is what led countries to adopt this mandate and this negotiation to happen. Now, with everything you're hearing about plastic, one could think that plastic production is actually reducing, and that those threats are actually taken care of because this is something that we've been talking more and more over the past few years. The reality is the exact opposite. As you can see on this particular graph, plastic production has been rising exponentially since a number of years and is expected to continue to rise exponentially. And that creates a growing threat, because if no action is taken, the volume of airborne microplastic, the one you breathe, the one you eat, and the toxic emissions of all the chemicals that are explained will automatically follow the expected rise in plastic production. What we mean is, if we don't do anything about this rise in production, more production will just mean more pollution, more health impacts. We're talking about more cancers, more obesity, more diabetes, more impacts on reproductive system, more impacts on child health, more impact on cognitive cognitive disease, etc. And so I want to leave you with a number of recommendations. The first recommendation is very simple. It's about reducing plastic production. If we don't reduce plastic production, we will not reduce pollution, and the impacts on health will continue to rise. The next recommendation is to have comprehensive regulation. It's to adopt a hazard and group-based approach. One of the things I didn't mention here is that one of the challenge we're having when we're regulating chemicals by chemicals is that once you regulate one chemical, it is very quickly being replaced by a similar type of chemicals from the same group, which assessment takes many years to identify the specific impacts, and that are in most of the cases just as toxic, if not more toxic. There are a lot of examples around bisphenols, around flame retardants, where regulations have tried to ban one type of chemicals. They've banned one type of chemical, but it was very quickly replaced by one of the same group that had the same health impact. And so comprehensive regulation focusing on specific criteria, the most problematic criteria: persistence, bioaccumulation, mobility, and toxicity. The third recommendation is to increase transparency. The only way you can adequately regulate a product is if you understand where it is. The only way as a consumer you can protect yourself from any impact and you can make informed choices is if you know what you're buying. The only way as a worker you can put in place protective measures to not be exposed is to know what you're being exposed in the first time. Right now, the moment that we're speaking of, nobody, and I mean nobody, not even the producers, the disposers, or anyone knows what's in any particular types of plastic products. And that's also a major issue for recycling, because if you don't know what you're trying to recycle, what you may be doing is actually recycling toxics and increasing the round of exposures. And so it's very important to establish a no data, no market principles, transparency about what chemicals are in what kinds of products, and transparency about what we know about the impacts of each of the chemicals at every stage of the practice. we need to simplify. The next recommendation is to simplify the complexity of plastics that we're using. Having to deal with an almost unlimited number of polymers and over 16,000 chemicals. Those of you who are a little versed in mathematics know that the combination of those hundreds of polymers and 16,000 of chemicals create an almost, or I was going to say almost infinite, that's not true, mathematically speaking, but a very, very large number of combinations. And that combination makes it extremely hard to adopt management measures and management practices that are adapted to reduce the risk. And so you need to put in place safe by design practices. And in order to do this, you need to drastically reduce the number of chemicals that are being used so that we're dealing with a material that is simpler, that we can know and that we can decide how to deal with. The last recommendation is the need for capacity building and strengthening technical and institutional capacity all around the world at the national level in each countries and each region of the world, but also the need for building and strengthening the technical and institutional capacity at the regional and local level, because this is very often when some of the primary decisions are being taken to regulate either production sites or who are responsible for the waste management of the various plastics. So thank you very much for your attention, and I'll be very much looking forward to further question further down this webinar. Thank you very much.
Thank you, David. That was very comprehensive. I mean, you practically covered the entire landscape of all the literature that we have. On that note, I would move to our next speaker for today. Our next speaker is Ritvik Datta. Ritvik is the founder of Legal Initiative for Forest and Environment, and he currently heads the organization as managing trustee. He graduated in sociology and law from the University of Delhi and has been involved in environmental litigation for the last 20 years. He is presently involved in litigation before the National Green Tribunal Principal Bench, as well as regional benches on subjects related to challenges to environment and forest clearance. He's an Ashoka Fellow and recipient of many prestigious awards. He's authored several books, one of which is with the current Minister of Environment, Forest Climate Change, titled The Supreme Court of Forest Conservation. So, Ritvik, the floor is yours. We would want you to touch upon what is this issue around plastics and human health covered by the existing law in India, in the global south, in the global north. What kind of work has happened on the litigation front, on the legal front, and what are the learnings from India or the global south? The floor is yours.
Thank you. Thank you, Siddharth, for inviting me, and also for Atin for moderating it. After the very insightful presentation by David, for me, it's not an easy task. So I'll limit myself more to the legal developments in India rather than getting into the details of how and what plastic composition is and what all problems that are there. And to thank you, Siddharth, you've already covered a significant part of the judiciary's role, especially the National Green Tribunal on Plastic. And so to that extent, I'll not repeat them, but, some of the issues that I've been involved in, and I'll be very frank in sharing some of the challenges that we face, right? And what I see as areas which would need more intervention and what are the opportunities that are there. So first and foremost, I think over the last 1 year, we have seen that there's been a lot of interest on the issue around plastic pollution. And so much so that one of the unique powers that the courts in India and the tribunal has, which I think many other jurisdiction does not have, is the suo motu power. That, there's no need for a petitioner to come before the court. The court itself can see a news report and based on the news report can initiate the case. So, so if you look at it here, over the last 1 year, 1.5 to 2 years, there's been a spurt of litigation where essentially there's been newspaper reports or reports like Toxic Link report, CSC reports, which have come up, and those were taken by the tribunal, as they call it, tribunal on its own motion, as petitions, and then they progressed further on it. But I think what is very important to understand is, a bulk of the cases that relate to plastic today look at plastic essentially from the waste perspective. So I think that is one very, very difficult aspect to, I won't say difficult aspect. This is one issue that one should be concerned about, because they seem to have belief that plastic is fine. It's only that the way that we manage the waste is problematic. And as long as we manage the waste, the use and the production of plastic need not be interfered with. It is with this entire idea that, this local group from Uttarakhand, Himachal, all of them got together. And this Him Jagriti case was filed in the National Green Tribunal. Now, interestingly, this is among the longest ongoing case, right? Because it's presently in the Supreme Court. And when you look at it here, what it says is that, well, we have the plastic waste management rules in India. It's been amended many times. But if you look at it there, it just concerns essentially with, to some extent, to production, to some extent, largely to the waste aspect, but very little to what could be the health impact of the use of plastic itself. Now the 4 to 3 studies that were done, one which you have definitely quoted correctly is the IITR, Indian Institute of Toxicological Research. Now, these studies were all done based on the directions of the National Green Tribunal in the Him Jagriti case. Now, in that case, the issue was simple, that in a tropical country like India, where there is a huge fluctuation, and you mentioned about 40 degrees, and 40 is a very normal temperature, but if you have a liquid exposed out in the open, then the temperature can go up to 65 degrees. So 40 is the ambient temperature, but inside the bottle, a liquid is exposed to 65. Now, when IITR and National Test House, all of them did the study, what was very clear about it is high amount of leaching, that too of antimony, lead, and of DHPs. And if you look at that aspect, it is serious because it is far more than whatever is the global or the national standards. It is also of concern that in many of the chemicals, we do not have any national standards at all. Now, there was not one but many committee reports of the Director General of Health Service, Ministry of Health, of all these committees, where they said that first and foremost, there is a serious concern about packaging of soft drinks, liquor, and liquid oral formulations. Now, why these three things are problematic is because they are largely acidic in nature. They react with the plastics, and that results in high level of leaching. Now, as a result, unlike, say, European countries, where the temperature is largely low, temperate countries and others, here we are exposed to high degree of temperature fluctuation. So what really happens in these instances is, well, you have a soft drink bottle transported in an open truck, exposed to 65, then kept outside the shop for display. Then only a small quantity reaches the refrigerator, where it is cooled to below 15 degrees, and then sold out. It again increases the temperature, then it again comes down. Now, this is where the leaching levels go up massively. Now, what is an issue of concern here is that we have not one Ministry of Consumer Affairs report, of National Test House, of Indian Institute of Toxicological Research, then you have of All India Institute of Public Health and Hygiene. Now, all our government bodies, all of them have said that this needs specific regulations. The reports basically said that the consumer must be given an option, that for every commodity that is there, that there must be a non-plastic options available for the consumer. So, for example, it is very clearly proved that for for medicines and oral formulation, it is extremely toxic. Now, the answer to that has been that, well, we will restrict that only when it comes to women of reproductive age, children, and geriatrics. Now, this is again a very limited interpretation, because if it is toxic for all. But unfortunately, they have not restricted that also. They have not restricted that. And for 10 years, despite the fact that there are government reports clearly proving that use of these chemical of these containers and packaging for liquor, soft drink and all is extremely toxic. There has been no regulation at all. And so therefore, I think what has happened today is that the entire focus definitely seems to be on waste, which is not a problematic aspect I'll come to, but that does not and should not blind us from the fact that it is the use of plastic itself which is problematic. And just to share with you, the case is now the Himjakriti case is in the Supreme Court for the last 2.5 years. There's been no hearing in this matter, right? And we don't know when it will come, but an issue of such serious concern, which actually impacts the life of every single person, is today hanging, despite the government very much aware of the fact that there is high level of toxicity. Now I think let's come to another aspect. And I think what I find is that so far as the waste aspect is concerned, despite many developments so far as or watering down of the legislation on plastic is concerned, it's a fairly robust legislation in many ways. And I think there what I find is that the level of implementation is poor, but I think the level of understanding the law itself is very limited. Now, just to give you an example, now we looked at the implementation of the act and very clearly found that styrofoam has been banned in India, right, for use of use for food items, for plates, for any of these things, and for decoration. Now you find styrofoam used all across. And till date, the implementation so far as styrofoam is concerned is next to zero. Now this is an area where the law is there. And I think the issue is implementation is not difficult, but there's been no effort to convey that you actually need to control styrofoam. Now, styrofoam is problematic. Now let's look at this whole issue of styrofoam. Now, it is problematic from the waste perspective because it litters your river system. It is there in the environment. But most problematic aspect is that in food, styrofoam is used for serving coffee, tea, sweets, liquid, and many of us know. I'm just presently in Calcutta, and every single sweet has been served in styrofoam. Now you look at it here. Now the aspect with regard is that okay, we will manage it at the waste, but the fact is the use of styrofoam itself is illegal. It is unhealthy. It is let's say it's toxic for all the reasons, and yet there is a huge gap so far as implementation of the same is concerned. That's there. Next, if you look at EPR, now EPR is there, it's the law, right? But so far as EPR is concerned, what we found again is the fact that it looks essentially again from the perspective not of health, but of the environment, which is nothing wrong about it. But the fact is that every single plastic product or even metallized product like Tetra Pak and all were being sold as paper-based packaging. Whereas the last layer, which is in contact with the food, is actually plastic. Now there, again, it needed a litigation in the Green Tribunal, Southern Zone, to actually bring both Uflex and Tetra Pak, which is the largest aseptic packaging carton manufacturers in India, within the fold of EPR. Because they said that globally, their stand here is that we are treated as plastic, as paper-based packaging and not plastic-based packaging, because only 21% of our product is made of plastic and rest of it is aluminum, paper and all. Therefore, we are paper-based. Now, again, the issue is that large number of products, whether it's milk, whether it's fruit juice and all, are being actually packaged in this aseptic cartons. And the fact of the matter is that the last layer in contact with food, in contact with liquid, is actually so thin, then it is thinner than what is normally permissible for food items. Now, again, there is no regulation which actually stipulates that if it is of such thin nature, it cannot be used for food packaging and all. This is again an area which I think has not been looked at very carefully, and it needs intervention at various levels to actually bring the entire aseptic carton manufacturers within not only the scope of EPR, but also in terms of regulating what should be the safety standards so far as toxic material is concerned. I'll not go further, but I'll just highlight one or two aspects here. And I think what has happened in many is that generally the idea is that the government's stand in many of these issues is that we need to use plastic for packaging. And this is on affidavits before the National Green Tribunal, because plastic packaging is climate friendly. Now, this has been the stand all throughout, that so far as fossil fuel is concerned, right now, David made a very, very important point that 99% of it is actually fossil fuel. Now, however, plastic manufacturers' point of view before the courts has always been that manufacturing and packaging in plastic is very, very important in order to reduce the carbon footprint. So if we are transporting alcohol, beverages, water in glass bottles, the weight is so much that the fuel consumption will go up. The only way that can be reduced fuel consumption for trucks, vehicles, trains and all is to reduce the weight of the packaging material. And the best way to reduce the packaging material is to move from glass to plastic. Now, therefore, in order to comply with various climate commitments, it is important to move to plastic, which is climate friendly. Now, this is an absurd argument, but just to tell you, this is the argument. Now, again, in all this narrative, what is happening is that you look at it from the waste perspective, or whether you're looking at it from the fossil fuel perspective, the health aspect doesn't get highlighted at all. And I think that is somewhere it needs a lot more civil society as well as doctors and activists and others to actually raise this issue. Because for me, what I consider as very serious is that there are at least half a dozen reports of government agencies, none other than IITR, AIHP, National Test House, which are all there in public domain, and which are very categorically stating that we need to move away from plastic packaging on health ground. The Director General of Health Service of Government of India has filed affidavit 8 years back saying for bulk of materials, we need to move away from plastic packaging because it has serious health concern. And the fact of the matter is, till date, we have not really addressed that particular issue, despite solid proof that PET bottles and others have serious health consequences. Now, I think the last point I want to just highlight is the fact that there is a huge amount of recycled PET bottles manufacturing that is been set up in India, which is going to come up in a large scale. And there, the recycled ones are turning out to be one where you are recycling the bottle along with the wrapper, where the brand is mentioned, that is PVC. So a lot of recycling is involving PET bottles along with PVC wrappers. And that is leading to significant amount of BPA in the bottle itself. Now, that is a standard, again, on which there has been no testing. There's been no study in detailed form. But the matter of fact is that in recycling, you are mixing large amount of PET along with PVC also. which can create a serious health impact. So therefore, though recycling may be to some extent good for the environment, what is the health impact arising out of this mixing, I think needs to be also looked at. So this is where I would like to end. Only aspect again of one point is that this suo motu jurisdiction aspect is very good where the courts are taking it up. But the issue of concern is that in suo motu, the court proceeds on its own. It doesn't have the benefit of a lot of health specialists to guide the court as to what needs to be done. And that, I think, is an issue which ought to be discussed, because it's great to have the reports in place. It's great that the court takes cognizance. But then the proceeding in the court is between a government lawyer, a plastic association members, and the court itself, with civil society or the authors of the report nowhere in the picture. And therefore, that can be like an unguided missile, which can actually lead nowhere or to the wrong place. So I think there is a great role of each one of us, especially health professionals and organizations, to creatively guide the court in the direction that they're leading. Thank you.
Thank you. Thank you so much, Ritvik, for taking us through how the litigation has basically evolved and how we are severely lacking in regulations in our very own country. I would now like to move to Satish ji. Satish Sinha is the Associate Director of Toxics Link. He has been associated with the research-based policy advocacy organization since 2003 and has been leading a team trying to affect change both at the policy and grassroots level. His knowledge and expertise on environmental issues, especially in the areas of municipal, hazardous and medical waste, food safety and chemicals, POPs, has helped him in taking critical issues forward in the country. He brings along rich and diverse management experience with him, having served with the Indian Air Force for over 20 years in various responsible positions. So, Satish ji, Toxics Link released a report not very long back, if I'm not wrong, earlier this year, where you tested samples of sugars and salts, various samples of sugar and salt for micro and nanoplastics. And if I'm not wrong, all of them were contaminated. So if you could just throw some light on this study and also connect it to how they might be affecting human health.
Thank you, Siddharth. Can you hear me? Okay. And thank you for inviting me to this webinar. And before I move forward, I'd like to just say that I think David and Ritik both have made my job easier by covering a lot of the issues, especially on microplastics. Because what I'm going to touch upon is microplastics. And sorry, just share my slides first. Just give me a minute. Yeah. Can you see?
Yes, sir. You can just go full screen.
Yeah, I'm just trying to. Thank you. So I'll just try and first break down microplastics as to what we mean by microplastics and what is the understanding for many of you who perhaps don't understand it completely. I think microplastics are nothing but smaller fragments of plastics or different resin core. And they are ideally classified by two different parameters. One is on size. So anything less than 5 mm will ideally be classified as micro. And then if you go further down by size, it is meso or nano. So anything less than 1 micrometer, it becomes a nano plastic. So this is how it is classified in our for microplastics. The second classification is also important for us to understand. There are two separate origins of microplastics. One is primary microplastics and the secondary microplastics. So what does primary microplastics mean? They are classified as primary, which are intentionally manufactured and released in products or used in products like cosmetic, detergents, soaps, shampoos, everything that you have, cosmetics, and they are used even in pesticides there are multiple uses of primary microplastics which are manufactured and they get released into the environment. So they also add the burden to that. And the second one is secondary microplastics, which are formed by degradation of larger plastics through mechanical, phytolytic, and biological processes. And they keep happening over time. And that's what is secondary microplastics. So we find more of secondary than primary microplastics in the environment. And as David has covered it very well, they're persistent and mobile in the environment. They cover large distances. They move globally through ocean currents and through air currents also, as he explained. I would like to say that smaller sizes and larger surface area allow them to absorb toxic chemicals, heavy metals, EDCs, and POPs. They absorb these chemicals and they act as vectors in many cases as far as chemicals is concerned. So that is the nature of microplastics as we know. So what are the other kinds of this thing? As I see it, we started working on microplastics in about 2016, 2017, and we have had a series of reports in India to our conditions. And the first report that we did was in 2017, that was on drinking water. Second was on microplastics in tap water in Goa in 21. Third was microplastics in cosmetics in 22. Microplastics in agricultural soil in 22 again. And then microplastics in River Ganga in 21. And microplastics in salt and sugar that Siddharth just mentioned was in 2024. About 3 or 4 months back, we released this report. So I'll just touch upon the microplastics in water. There were 3 reports that we did in microplastics in water. There were 2 TAP reports. One was the TAP report from Delhi City, and that was a part of a global study which we part with the US organization, and the samples were all shipped to US, Minnesota University, and it was tested there. And from India, I think over 80% of the water samples that we sent from tap water from various parts of Delhi, it was contaminated with microplastics. There were different kinds of levels of pieces that were there. The range was between 0 to 57 particles per liter. And you can come back to a mean of 4.34. So that was our first study. The second study that we did, and we repeated that, I'll come back to this, Goa tap water. We did about 11 tap water samples in Goa at various places, and we again found large number of microplastics in Goa tap water. And the third study that we did was from River Ganga. We picked up samples from 3 different locations. One was Haridwar, second was Kanpur, and third was Varanasi. And in all these samples, we found significant amount of microplastics. The least was in Haridwar, as we can make out, is upstream. Midstream, Kanpur, we found a lot of textile and fibers in it. And in downstream in your Varanasi, we found multiple materials in the water in Ganga. So this was what confirms our report or data that surface water is contaminated, has microplastics in it. Even our drinking water in major cities is contaminated with plastics, microplastics. There was another study that we did in between, which was packaged drinking water. We tested packaged drinking water also, the bottles that we get. And we found that they were also having microplastics in it. We don't know what the sources were. I think there is need for more investigation for this. The other report is microplastics in soil. This we did in the 2 states of Maharashtra and Karnataka, because they use mulch in these 2 states quite significantly in large quantities. And both these places, we checked for the soil where they were using mulch, and we also had control samples. And the findings were very, very interesting, that we found microplastics in most of the soil samples in different concentrations. There were concentration in the top soil. There was a little less in the medium soil. At different depths, it was slightly higher. And again, as you go down, it reduced. So there was a lot of microplastics of different kinds of resin core that they were using. It also is not only mulch, but a lot of agriculture practices have pesticides, tools, fertilizers, all that is bagged and produced. And even for bagging of their produce, which they finally harvest, that is also packed in plastic bags. So that also contributes to the plastic pollution that is there in the soil. And I think preferred disposal practices that we observed in these places on farm was burning or landfilling in the areas adjacent to their farmland. So they also attributed to the contamination of plastic in the soil. So these were a couple of studies that I just wanted to mention, that these are Indian data from Indian states, and they do confirm that soil has microplastics, and during rainwater runoff and floods and otherwise, all these are carried down to our surface water streams and from there to oceans and other rivers. And that is where it comes back to us in drinking water form. I'll touch upon salt and sugar study that Siddharth just mentioned. And why did we do this study this year? It was for a reason that these are two most consumed items by every citizen and all over the world. And it was something that we were intending to do for long. And also we were getting a lot of reports about the microplastics presence in human organs, as David mentioned, that all organs of the human body has microplastics in it. And so we thought that we are perhaps consuming it through water, and but then what is the other dietary this thing intake that we have, and how do we account for it? So we tested salt and sugar, and as we can see that we consume about recommended is 5 grams salt, but we Indians consume about 10.98 or 11 grams, which is far higher. And sugar we consume about 18 kg per year. This is also we have taken from data. So what we did, we picked up 15 samples of both salt and sugar. Salt was 10 and sugar was 5. And we picked up all kinds of salt: iodized, local salt, sea salt, rock salt. And these were all there. We picked up from from online and from the local market. And we also picked up from some distance away. And sugar, we picked up 5 samples. We sent it out to a lab in a teaching institution which had the capacity to do this. And this was the protocol which was followed. And the instrumentation that we finally used in this case, the institution used, it was Manipal Institute of Technology, which did this testing, and they had previous record of doing this kind of testing, and they continue to do it. So it was an institution which had requisite capacity, and they followed the protocol, which was globally accepted at this point of time. They used FTIR, ATIR for identification of the plastic resins. And what we found was that highest concentration of microplastics was noticed in iodized salt samples, which we use most often in India. We have been, there's a recommendation that we should use iodized salt sample, but this had the highest. Not sure why this had the highest, 89.15 pieces per kg of dry weight. And the lowest was rock salt, was 6.7 pieces per kg. So this was in salt. Among the sugar was 5 samples that we tested. This also had microplastics, and it was about 6 pieces, and it was 11.85 pieces. So this was again what we found in both salt and sugar, and all the samples had it. There was not one sample which we could say that it had no microplastics in it. So this was something which was quite startling for all of us. But it was also not so startling because there have been previous reports in India which have been done by other institutions which had similar kind of reports. Even IIT Bombay has reported a similar kind of report in salt studies. What we found about size, in the smaller size fractions, 0.1 to 0.3 were more as compared to 1 to 5 mm fractions. So smaller fractions were much more as compared to the larger fractions. Color, microplastics in 8 distinct color was present: white, blue, red, violet, and all other colors that we can see. That could be from the origin of the plastics resin that we had, or from where from the breakdown was happening, and what was the color of the original plastic, which dye was added to it, and that is why the color comes in when you test the plastic microplastics. Fibers were dominant category recorded, polymer details. And we also found the presence of LDP, HDP, and PET in all the microplastics that we tested, especially in salt and sugar. So this was the finding of this thing. So it does give us a complete data that most of our food items today that we're talking about has microplastics or nanoplastics in certain quantity. And we all are now exposed to this. As we just heard about it, that what is hazard, what is exposure, and how do you calculate the risk. And I think they all become very, very important. These are other studies. This was not the only study that was done, but all other studies across the world, Australia, China, India, Spain, Italy, France, Thailand, Turkey, US. These are all the countries where these studies have been done, and they reinforce the same data that we have produced. And we come to this final result or analysis that most of these items are now contaminated. Now, where does this come from is something very, very difficult to identify. It requires much more of analysis. But one of it is also, I think, sea salt could be from the kind of plastics that are finally landing up in the ocean, or microplastics. The second could be the processing, the packaging, the transportation, and the retaining process. They all could contribute to microplastics in both the salt and sugar. So this is, again, a matter of great in-depth study which can identify this. And because if you have to find a preventive measure for it, we need to understand as to where is it coming from. So this sugar was not so easy to find across the literature that we did. There was only 2 studies that we found. One was from Bangladesh, and the second was from Germany. Both these said that there were enough quantities, similar kinds of data was from both these countries. Again, the question that will arise as to where does it come from in sugar is a slightly difficult question to answer, but it is a fact that it could be from the soil, or it could be from water, or it could be during processing, or it could be during packaging. But fact remains that it has. Some of the toxicity about microplastics that we talked about, and I think David has very clearly highlighted that microplastics have the same characteristics as plastics, and they're majorly made up of a lot of additives which could be toxic chemicals. A large number of these chemicals could be endocrine disrupting, or they could be persistent organic pollutants with multiple kinds of toxicity. They could be carcinogen, they could be endocrine disrupting, they could be neurotoxic, they could be nephrotoxic. So all these possibilities are there, and we get exposed to it, then obviously they are released into the body, and they are likely to contribute, or they must be contributing to some of the health impacts that we are now currently struggling with. I have a chart here which does tell you as to what is the intake level for different, how do we get exposed to some of these chemicals. I think water is something that is there. But maximum is fruits and table salt, fruit, vegetable, table salt, and butter. The other thing that I just wanted to mention, that air could also be another reason for microplastics, because smaller particles of microplastics could be possibly in the air, and what we breathe in and what goes into our lungs could be microplastic. So some of these that we've been talking about, particle 2.5 and 10, that also we need to identify as to how much of plastics is there in it. So this is how, if you look at it, this is the intake level of human body, and this is an annual intake, and we are exposed to much more of micro and nanoplastics than what we all of us tend to think, and they are likely to have serious health impacts. It's very difficult to say as to some of these toxicity levels, that toxicity characteristics of these chemicals are, they could be disruptive to immunity, metabolism, oxidative, cytotoxicity, neurotoxicity, carcinogenity, and reproductive toxicity. Especially endocrine disrupting chemicals could be reproductive toxicity. They are known for it. And some of the testing which has been done in India also on reproductive toxicity for EDCs, have been interacting with some of the scientists at the National Institute of Reproductive Health in Mumbai, and they do carry out testing on laboratory species and not on humans, but so they have done in rats and mice, and there is ample evidence that there are significant changes to reproductive health of many of these samples. They will likely to have more. So I wouldn't be able to say at this point of time most data and suggest that there is likelihood of serious impacts, health impacts, because of the kind of chemicals that many of these micro and nanoplastic has, and human beings are exposed to it. They are, I would say that in the final analysis, I would say that they are largely contributing factors to many of the disease patterns that we perhaps see, but I think there is requirement for more clinical evidence and more research on these aspects. So that's all from my side. Thank you so much. And if you have any questions, I'll be happy to answer. Thank you.
Thank you so much, Satish Ji. That was very insightful. We are running way behind time, but I'm sure, with the permission of the panelists and the participants, I would want to extend this very interesting conversation that we are having. Our last speaker for today, but definitely not the least, is Dr. K. Srinath Reddy. He's an honorary distinguished professor at the Public Health Foundation of India. He's the past president of PHFI and formerly headed the Department of Cardiology at AIIMS. He has and continues to advise several state governments on the issues of health, including the government of Odisha and Andhra Pradesh. He has served as a physician to two prime ministers of India. He was the lead negotiator for India in the Framework Convention for Tobacco Control, FCTC. His contributions to public health have been recognized through several awards and honors. They include WHO Director General's Award for Outstanding Global Leadership in Tobacco Control and Padma Bhushan, which is the presidential honor in India. He was awarded this in 2005. So, welcome, Dr. Reddy. We are privileged to have you. And like we discussed, that a negotiation is ongoing to deal with the issue of plastic pollution, and human health and plastic pollution across the life cycle are linked, as all the speakers have pointed out, and we have evidences that are documented. So I would want you to draw some references from the FCTC that has health as the center of the convention itself, and also on the conflict of interest, because this happens to be the only convention that has an article that prevents companies or agencies with vested interest to not really have a very strong say. So, Dr. Reddy, the floor is yours.
Thank you very much. This has been a very educative experience for me on the pervasive perils of plastic pollution at the population level. Indeed, I think all the issues related to the health harms in terms of their diversity and intensity have been very well covered in all the presentations. And the issues that have been raised are how best to deal with it, both upstream and downstream. And I think my own contribution at this point in time is to flow back to the dynamics of an international negotiation, which I saw firsthand at FCTC, and see how best that can inform the ongoing negotiations in the plastic treaty discussions. Indeed, in any international global health issue where there are negotiations that are undertaken or global health consensus is attempted, I think there is a flavor of what I call SPICE. S for science, P for politics, I for industry, C for civil society, and E for economics. Let me start with the science part of it. Science, I think, is absolutely clear as to the harm being done, whether it was tobacco or whether it is plastic exposure in terms of the intrusion into the human body, damaging multiple organs and resulting in several types of disorders. It is important, of course, to have that science base available even before the treaty is initiated, because the treaty wouldn't have really come to the table if the scientific argument and the public health impact or the economic impact was not already presented. Nevertheless, even during the course of the negotiations, it needs to be reiterated, because there will be subtle attempts by the affected industries to undermine the credibility of the scientific evidence or the generalizability of the scientific evidence gathered in one part of the world to other parts of the world. So it is important to keep that very much in mind. Usually in an international negotiation, that is dealt with in the preambular part and also possibly during the initial opening ceremonies of the negotiations. But the side events provide a tremendous opportunity to continue to stream the messages about the nature and severity of the health harms across the life course to the various convention delegations. It is important, and that's where the civil society partnership can play a great role by inviting a variety of experts to side events, whether they're lunchtime events or end of the evening events or whatever other side events are there. So that is a message that continues to be beamed up. And that is important for us to tell people what is the nature of exposure, the route of exposure, the impact of long-term exposure, intensity of exposure, and all of that. And it is important to tell also in not only in terms that are absolutely appealing to the rational scientific mind of the policymaker, but also to the emotive element as well. I mean, if we really talk about, which is true, of microplastics being found in the breast milk and in the fetal brain, that is something that definitely has a potent effect. So the scientific message, which is factual, needs to be reiterated at various opportune moments. The second, I'll get back to the last one, the economics part of it. The economics is very important because that's going to be a contested area. And apart from the question of who is going to be affected, what kind of employment will be lost, how do we actually have ethical transition, all of that is going to be an important element. But listening to the preceding discussion, it was very clear that this whole business of whether we should only suffice with demand side actions or disposal side actions in the case of plastics, or also undertake supply side actions. We had this debate during the FCTC negotiations, when India and a number of other developing country delegations, which were particularly at that point in time involved in tobacco production and export, wanted in earnest to disengage as much as possible from those activities, but said there needs to be a transition, which is facilitated transition for helping tobacco farmers and workers to alternate occupations. The developed countries, which were not tobacco producers, negated it and said, no, this is an argument that you're actually raising in order to evade your responsibility for tobacco control. The World Bank actually said you're walking into the trap of the tobacco industry, because the tobacco industry does raise the issue of how much of employment is going to be lost. But equally importantly, sufficing only on the demand side is not going to really work, as we know. In tobacco, when you had actually controlled cigarettes, the BDs went up. When the BDs were being controlled, oral tobacco products went up. And elsewhere too, when cigarettes were being controlled, the tobacco industry diverted it into vaping products. Even in India, when we had the fall of the Soviet Union and the various developing country markets opened up to US and North America in terms of tobacco trade, we lost our captive ruble market in the Soviet Union, erstwhile Soviet Union, and we landed up with a tremendous tobacco surplus. And that is when the gutka packets started appearing in India, because that became the alternate route when they had excess tobacco, which they could not export. So we know that unless supply side action is also taken, purely demand side or disposal side action is not going to really help. So this is a point that needs to be made very clearly. And India did fight for it during the FCTC negotiations and got a particular article inserted for easing economic transition to alternate viable occupations. How well that is implemented is a different area, but it needs to be there very much in the treaty. Now, coming to the questions of politics, there will be alignments, opportunistic and political alignments that will happen during the course of the negotiations. For example, we found that the English-speaking high-income countries had a bloc where even if some of them were actually active in tobacco control domestically, they would support the United States on formulations which would diluted tobacco control globally. So you'll have to be aware of these. But the countervailing force was a bloc of developing countries which joined together and fought together on a variety of issues. So you'll have to really explore during the course of the negotiations how best these kind of alignments can be brought in. Fortunately for us, the WHO also had regional consultations before each round of the international negotiations. So each region of the WHO, whether it was CRO or MRO or AFRO, had their own regional consultations and debated each of the new drafts, and then went to with a reasonably agreed position to the table. So alignment across the various developing countries was not difficult during the negotiations, though there were attempts made to divide us. So I think that is a very important element that we must have, that there have to be alignments, recognizing that there will be alignments on the other side too, of those opposing any effective action. And the role of the civil society is very critical. Civil society doesn't usually have a seat at the negotiations. Some of the agencies that are in official relationship with the UN agencies may be invited to comment, but they really can't really influence the negotiations. But they can, in the side events, in the corridors, they can actually play a tremendous role in continuing to educate and motivate the delegations, and they should be appropriately utilized. And they can actually bring in fairly eminent experts for side events and ensure that the message is continually beamed to the delegations. I mean, these are the dynamics of the negotiation that I was really talking about. But it's also very clear that one of the things that we believe, that while the negotiations may have several articles, it is important to keep the messages very clear. Why tobacco control succeeded was partly because of three factors. One is there was a sense of outrage. The outrage was that innocent people were being affected. As long as tobacco consumers who actively chose to smoke, even though they were enticed and entrapped into the habit, it's not entirely their fault, but they were active smokers. If they suffered the penalties of health consequences, the governments and the public didn't pay that much attention. But when passive smokers who had no intention of smoking but were exposed to tobacco, environmental tobacco smoke, whether it was women and children or co-workers, then the outrage came in, and that brought in the tobacco control movement to the negotiating process. And the governments agreed. So I think it's important for us to ensure that we keep our messages also fairly simple, both at the cognitive level and at the emotive level. As I said, the asks were very clear. There were about 5 asks that we had during the major negotiations, categorized, you might say, with different articles, of course. One is ensure that the taxes are raised so that the purchase by the consumers becomes less affordable and consumption comes down. So economic measures, fiscal measures will have to be definitely imposed. I'm just drawing parallels with the Tobacco Convention. The second was environmental tobacco smoke. The third was health warnings. And the fourth was support for cessation and so on. So we had very clear-cut basic demands which could be definitely brought in to keep the attention of the policymakers rather than a big laundry list of demands. But then that is where you'll have to make sure that the convention itself, even if it has several articles, as some of the key measures highlighted repeatedly, because the attention should not wander, because there will be attempts made by the industry, through some of the delegations, to dilute the process, divert the attention, and to have endless debates and a multitude of brackets around the formulations. So it is absolutely important that we keep the message fairly straight and clear. The other element that I would like to bring about into the whole process is related to what I call a sensitivity towards the alignments that are there in different countries. Even when we found that some of the countries who are fairly active in tobacco control domestically were not willing to support strong measures internationally, because one or two of them in their high-income country bloc were not favoring tobacco control process. But that is where you'll have to mobilize their own domestic civil society constituencies to put pressure on them. So this is a continual process of negotiations which will go on. But I think coalition building is also very important with others who have a similar objective. The whole idea of how food products are being contaminated by plastic exposure has been brought out very well in the previous presentations. There is a very good article that's been published in Globalization and Health on October 24th, just a couple of weeks ago, which talks about the toxic relationship between ultra-processed food and petroleum products. If you read the key message, it says they provide the full evidence of how petrochemicals are leaching out and leaking out into the food products, and ultra-processed foods in particular are quite dangerous in that, both in terms of production and packaging. So a key sentence in that is, quote, if plastics and petrochemical industries need each other, then the food system is their life buoy. It is absolutely true that they are going to be aligning. So it's absolutely important that the alliances have to be built of those people who are opposing ultra-processed foods, want the food and agriculture industry to be much more health-friendly. People are interested in biodiversity, not just human health, but also animal health. Those people are interested in animal health. All of these people will have to be brought to the table somewhere or other. And if they will not be part of the delegations, but their voices will have to be heard at the side events. And there has to be that coalition that's built up, which becomes a public health movement. And therefore, the environmentalists, the public health activists, the people who are interested in biodiversity, the people who are interested in healthy food and nutrition, and therefore, all of them will have to be really brought together as a coalition. Unless that public health movement is reflected in strength alongside the negotiations, it will be easy for the delegations to be distracted and diverted by interests who do not want a strong treaty. So this becomes a very important element. And of course, having good lawyers either in the delegation or the invited speakers is going to be very important in terms of ensuring that some of the drafting issues are not dodging the critical formulations, because the draft may actually be very attractive to read, but very misleading in terms of its ultimate impact. So these are important issues that I would suggest. But I believe it is important to build domestic coalitions as well, because unless those domestic coalitions continue to exert pressure on the governments and through the government onto the delegations, it is easy for the political will to be lost. And unless there is that political will, we will not be able to push an effective treaty. So that constant pressure has to be kept up. Fortunately for us, during the tobacco control negotiations, India also initiated its own domestic legislation. And that came about because of the public health movement in India for tobacco control. The net result was that while the FCTC was passed in May 2003, the Indian Parliament had already enacted the Indian tobacco control legislation in April 2003, 1 month before. So we ran parallel, we were fairly aligned in our objectives, and therefore we could argue from a position of strength at the international negotiations. So whatever we are doing internationally also has to be backed up as much as possible by domestic advocacy and domestic mobilization. And that involves a lot of coalition building. And I think that's very important to bring the scientists, the economists, the civil society, and others into play, and make sure that these coalitions are effectively articulating a combined consensual opinion. Thank you very much.
Thank you so much, Professor Reddy. It was very insightful, excellent discussion by Satish Ji, Ritik, and David. We have overshot by about 16 minutes already, but we still have close to 200 people with us. I could see that Siddharth has answered many questions while the discussions were going on. I would just request permission from all the panelists to stay with us for about 5 more minutes so that we can take maybe at least one question for each panelist. So Siddharth, could you please pick up the question and let the panelists quickly respond? And then we'll try and find other ways because we have your contact details while you registered for the event. So we'll find other ways to get back to you with the questions that we haven't been able to answer during the event. Over to you, Sid.
Yeah, so lots of question. Apologies if we would not be able to take them. But yeah, what I can make sure is for the ones that are not answered during the webinar, I can try and mail the answers back to you. And if needed, I will also try and reach out to the panelist if I don't have the answers. So there's one question for Satish Ji. It's, do we have any state-specific data on microplastics in Andhra Pradesh and Telangana? And also another question that is linked to this is how do microplastics go through various barriers in the body before they reach, let's say, breast milk or human hair? So, Satish Ji, if you could kindly
Thanks.
take.
I'll try and answer the first question before. No, we don't have any state-specific data. I'm sorry. We don't have any state-specific data. I don't think it has been collated in India so far on microplastics. But I don't see any very great variance between a state to a state on the prevalence of microplastics in surface water or groundwater or tap water. I won't be surprised if the data from across the states have similar pattern. And I have a reason for saying that because the kind of waste management practices that we follow across the country are by and large similar. The kind of challenges that we have in disposal of plastics are similar. And even the recycling patterns and other issues are almost common across the country. So I don't think there'll be much difference in how the surface water and tap water will be. I think the question is coming from there, that do you have data for other states on tap water and surface water? There are studies which have been done in other rivers, but tap water, I don't think much study has been done. So that's my answer one. I think most of the nanoparticles, which are far smaller in size, they have the potential to cross through the barriers. And I think when you intake plastics, it goes into this thing, body. That is the first thing. Through alimentary canal, the chemicals can reach out, or through other parts of the body, your chemicals can leach out and reach into different parts of the body. Through placenta also, it can reach to the fetus. It doesn't have to be the microplastic which has to go, but the chemicals which are there will leach in many cases. Chemicals that are adsorbed or chemicals which are inherently present in the microplastics will have the potential of leaching out, and that is how it reaches into different parts of the body. That's my understanding on the subject. If somebody has more, I think you are most welcome to substantiate it.
Thank you, Satish Ji. Ritvik, this one I think you could take. It says that as per Indian laws, by when do you think that Indian consumers can expect that are packaging food, cosmetics industry would be either plastic free or at least have proper labeling mechanism.
It's a very difficult question to answer, because as a lawyer, this important case is before the Chief Justice, and their lot depends on both astrology and God, as he said recently. So, on a lighter vein, but on a serious note, I think a case in the court, where we do expect a certain action to take place, is dependent a lot on public, sharing of information or public debate or information that is shared, so that the kind of environment is built up where the courts feel that there is a need to give directions, and the government also feels compelled to come up with these kinds of regulation. So I think it is something which will need multiple actors to play the role. And to that extent, I think I'm not saying we have not made progress. The fact that today this discussion is happening, the fact that whether it's CSE, whether it's Toxic Link, whether it's many other organizations which are repeatedly coming out with these reports, I think do have an impact on policymaker and on the judiciary. So, for example, today I find that when cases go to courts on, say, plastic, the overall approach of the court is that it is a problem that needs to be dealt immediately, right? So to that extent, I think that kind of changes today happened. I have not seen a judge where they're saying that, well, we can do, we should not highlight this health impact, waste impacts and all. I think it's happening, but I think it needs a little more push now. And I think the GPT and all these other international negotiations happening, I think will create the necessary environment for effective legislation, regulation to take place. And I think most important, as I find, is that there is, unlike other laws on environment, I think the plastic law, a lot needs to be done by civil society people to make it work. It's like the right to information. The government and the parliament will enact a law, but it's ultimately for citizens to make it work. So plastic legislations can work only if there is effective action by citizen group and pressure that these legislations, especially on health and the regulations that are there, needs to come immediately. We can't wait forever for that to happen. And that would need all actors to work together.
Thank you. Thank you so much, Ritvik, for that. And thank you to David, who has been diligently answering a lot of questions in the Q&A box. David, one question which I see, and I think that you might have some views on that. It says that it's quite evident that plastics affect human health. Who is to blame for all of this? Is it the producer? Is it the consumer? What do we prioritize? Profits and economics over health of our citizens? I know it's a very tough, and probably all of us know the answer to this, but yeah, I would like to listen to what you have to say.
Thanks very much, Siddharth. And this is a very broad and very large question, and unfortunately, one that doesn't restrict itself to plastic. A lot of questions could be asked about a number of our industries or the consumption good that we use or that are sold to us, and that are in fact having very negative impacts on our health and on the planet's health. One of the traps that this question highlights is the common approach by producers of toxic material, toxic products, to blame it on the consumer, or to hide behind individual consumer responsibility. We know that around plastic, the plastic problem is the fault of the consumers who do not put things in the right garbage. We've seen that, as was mentioned by Dr. Reddy, about tobacco use. We're seeing this about fossil fuel users. This is I would say, 101 playbook way to avoid accountability. What's interesting to understand that is to see how well documented this is as a strategy by the industries that do this. There were also a lot of questions about recyclings in the Q&A. I try to address as many as possible. And there's a link between those two questions. There's a link between the way we now all think of recycling as a solution to the plastic problem overall. Now, what's interesting to see is that recycling was originally advanced and pushed forward as a solution by the plastic manufacturer themselves in the 70s. But if you look at the internal documentation from those industries from the 70s, what you see is that from the beginning, they knew that the plastic they were manufacturing were not safely recyclable, that were not economically viably recyclable. But for them, they still invested massively into communication strategies to convince consumers that recycling was the solution. And you see it very clearly in internal document and declaration from executives from the 70s, from plastic producers in the 70s, where they say, we need to convince our consumer that recycling is possible and is a viable way out, because otherwise they will stop buying our products. And we need to keep buying our product. But from the very beginning, they knew and understood both the toxicity of the recycling processes, and of which I've tried to provide some elements into responding to the question, and the fact that there was no process and there was no economic viability in the recycling as it existed today. One of the big challenge, one of the big limitation of recycling today, even if we could do safe recycling, which currently we can't do, but let's assume that we could do safe recycling today, economically, it's impossible because the cost of virgin plastic is so low because fossil fuel are heavily subsidized, because the production of plastics are heavily subsidized. The cost of primary plastic is so low and recycling operations are so complex. You need to collect the plastic, you need to sort among the very many types of plastic that are put on the market. You need to adjust the material to actually do this. And the cost is so high that today the cost of recycled plastic is 1 or 2 orders of magnitudes above the cost of virgin plastic. And not only this, because the nature of plastic that I described earlier, the big long polymer chain and the additives, not only is recycled plastic in some cases more toxic, it is of lower quality because the way we recycle plastic is that we shred the plastic, we heat it, and through this process, we destroy the bonds in the long polymer chain. And so we create lower quality plastic. And in fact, I will finish by this. When we talk about recycling, we think of a circle. We think of something circular, like we think of for glass, for example, or for some metals. But plastic recycling doesn't exist. The only thing that exists is plastic downcycling, because every time you recycle plastic, you destroy some of the bonds. And so, one, you create lower quality plastics, and 2, a lot of it goes up in smoke, quite literally. And so, if you want to if you try to recycle 100 grams of a particular polymer, what you get at the end of it is about 60 grams of that same polymer. And so you have to re-add some virgin polymers to this to create a similar object, even if you could. But again, the plastic is of lesser quality. And so this whole myth of recycling being a solution was actually engineered and sold by the plastic manufacturer, just as the same way as the fossil fuel industry have sold us and are still selling us fake technological solution, or the tobacco industries have sold us fake science and have attacked manufactured doubt about the real impact of their product. So it's not to say that recycling has zero role to play in the future of plastic, but as long as we manufacture and design plastics that are toxic, there is no way we're going to have safe recycling. What we'll do is create a circular economy of harm and circular economy of health impacts.
Thank you, David. That was, I mean, you were able to kind of address a lot of things in that response, but that what you just said ties to my last question, which is for Dr. Reddy. Dr. Reddy, I think we spoke about this conflict of interest, which basically means that any entity with a vested interest may not really have a say or a seat at the table. This is embedded in the Framework Convention for Tobacco Control. How do you think that, or if at all you think that is possible for the plastic treaty in the coming days?
Well, I think Article 5.3 in the FCTC, which actually embodies this, is a very important contribution. It makes it very clear that national governments should not engage the industry while making policy. Because there is a clear-cut conflict of interest over there, and that can lead to a lot of distortion in the kind of policy that's being formulated. The question, of course, is if there are representations that are being made, they can certainly be looked at for whatever reason, and they will do it. The industry will have its own ways of raising its voice and reaching to the policymakers. But in the formal policymaking process, there is no room for the industry, which is a polluting industry or a health-harming industry, to play an active role in deciding how the policy should be formulated. I think Article 5.3 is very clear in that, because the tobacco industry has been known to be a very corrupting industry. It has bought politicians, it has subverted a variety of tobacco legislations, it has resisted, delayed, diluted, and defeated a number of regulatory actions that governments have taken. So getting them onto the table essentially means a very deficient and defunct, possibly defunct policy. The same thing should apply even to polluting industries. And I completely agree with this idea that trying to make the individual responsible for ultimately changing the overall nature of harm is absolutely incorrect. The industry, whether it's tobacco or others, will take a very libertarian attitude and say it is entirely up to the individuals to make their choice. It is not for a nanny state to make the choices for them. But choice is not sui generis. Choice is conscious, based on either the right or wrong information. And quite often, wrong information is given. And of course, with Mr. Musk in control, one never knows how much more wrong information may come in. Then we also have choice is not only conscious, but it's also conditioned by aggressive marketing and promotion. And that can be extremely a powerful pressure on the consumer's mind. And thirdly, it's constrained. So it's constrained also by the fact that there may be economic factors at play. Therefore, governments have a responsibility to make sure that the healthy choice is the more affordable choice, whether in terms of food products or whether in terms of packaging. So the governments will have to invest their resources in providing the consumer that choice, rather than they insist that the consumer has the freedom to make the choice when there is very little opportunity for the consumer in terms of availability or affordability. So the governments will have to take a proactive role and not to be derailed by tobacco industry interference, or in this case, the fossil fuel industry interference.
Thank you so much, Dr. Reddy, for that response. I will now hand it over to Atin for the vote of thanks.
Yeah, I mean, honestly, I second Professor Reddy and also Ritvik. Like it has been a very educative experience even for me personally. And now I'm just trying to understand and explore how we can collect all the materials together and at least raise a concern and engage with the policymakers and communicate our concern. Of course, we are going to be there in Busan, uh, which will give us more opportunity to learn more from the discussion itself. And Professor Reddy mentioned, that we'll try to use the opportunity to engage with stakeholders in the side event to find out who can involve and who can influence them a lot more. So thank you to all the panelists from the bottom of my heart. And thanks to all the participants, and my sincerest apologies to all of you for overshooting the time for more than half an hour. This entire discussion has been recorded and we're going to put it up in YouTube so that people who missed it, you all can just visit YouTube and share the link with people who couldn't join for other priorities. We have two more webinars lined up in this series of run up to Busan, the fifth Intergovernmental Negotiating Committee meeting. The next one is on the 13th, when we are going to discuss the plastic pollution fee or financing plastic pollution management versus the EPR regime, the extended producer responsibility regime. And we have our last and final webinar on the 19th, when we are going to release a report which will give you a bird's eye view of all the countries. All the countries means there are almost 190 member states in this ongoing negotiation process. So how they have positioned themselves, it's an infographic report. We published similar report just ahead of INC4 in Ottawa, Canada. So we are going to release this report on the 19th. I have shared the link in the chat box. And as usual, our outreach team will try and reach out to all of you. So do register and come back so that you all are part of this entire journey to this run up to the fifth INC. I once again thank Satish ji, Professor Reddy. Ritik had to leave for some other priorities. So is David. So thank you all so much for your insightful discussion and time and participation. It has been extremely useful for all of us, even for me personally and for Siddharth. So on behalf of CSE and all my colleagues and Siddharth, thank you all so much. Take care, stay safe, and goodbye.